Let ABC be a triangle where M is the midpoint of AC and CN is the angle bisector of ACB with N on AB. Let X be the intersection of the median BM and the bisector CN. In addition, triangle BXN is equilateral with AC equals 2. What is BN squared? We have triangle ABC here, where M is the midpoint of AC, and it's given that AC equals 2, so AM and MC are equal to 1. It's also given that CN is the angle bisector of ACB with N on AB, so each of these angles are equal. I will call them each theta. And then X is the intersection of BM and CN, creating equilateral triangle BXN. So in triangle BXN, each of its angles is equal to 60. And from there, we angle chase. We know that if angle BXN is equal to 60, then angle BXC is equal to 120. So that's equal to 120. And using the sum of the angles in a triangle, it's always equal to 180. So in triangle BXC, the sum of angles X and C is 120 plus theta. So angle XBC is equal to 180 minus that, which is 60 minus theta. Angle CXM is equal to 60 as well. And angle XMC is going to be equal to 180 minus angle X plus angle C, which is 180 minus 60 plus theta, and that's 120 minus theta. And 180 minus that is this, which is 60 plus theta. And using the triangle angle sum on triangle ABM, the sum of angles B and M in that triangle is 120 plus theta, so angle A is 60 minus theta. And if angle BNX is 60, this must be equal to 120, and so is this. I believe that's it. We've labeled everything in triangle ABC. From here, having all our angles labeled, we notice that angle CBM is equal to 60 minus theta, but that's also equal to angle BAM. And this implies that CB is tangent to the circumcircle of ABM. So if we draw in the circumcircle of ABM, then line segment CB is tangent to that circle. So we can use power of a point to get the length of CB, because we know CM and MA, they're both 1. So by using power of a point with point C, we have that CM times CA is equal to CB squared. And CM is 1, CA is 2. So this product is equal to 2, and that's equal to CB squared. So we now have CB equals root 2. Now from the angles we've labeled, we also can get some similar triangles. The first one we notice right away is that triangle CNA is similar to triangle CXB, because both of the angles at C are equal. They're equal to theta. Angle N in triangle CNA and angle X in triangle CXB are both equal to 120. And angle A in triangle CNA is 60 minus theta. So is angle CBX. So all three angles in these triangles are equal. That means the two triangles are similar. So we know that CN over CA equals CX over CB. Now I'm going to label some of these lengths. I will let CX equal little x, and the side length of equilateral triangle BXN, I'll let that be equal to A. So we want to find A squared. Now we can rewrite this similar triangles equation, CN over CA equals CX over CB, in terms of X and A. We know that CN is equal to X plus A. CA is just 2. CX is just X, and CB is root 2. So if we multiply both the left and right side of this equation by 2, we get X plus A equals root 2 times X. So we can solve for A in terms of X. That's just root 2x minus X, which is X times root 2 minus 1. So now we know that A is equal to root 2 minus 1 times X. We can substitute that when we use law of cosines on triangle BXC with the 120 degree angle at X. So using the law of cosines on triangle BXC, we get that X squared plus A squared minus 2 times X times A times the cosine of 120, which is negative 1/2, is equal to CB squared, which is just 2, since CB is root 2. So that means X squared plus A squared. Negative 2 times negative 1/2 is just 1, so that cancels out. x squared plus xa equals 2. And now is the time to substitute a equals root 2 minus 1 times x. So we have x squared plus root 2 minus 1 squared times x squared plus root 2 minus 1 times x, which is just root 2 minus 1 x squared. And root 2 minus 1 squared, let's do that. It's just 2 plus 1 minus 2 times root 2 times 1. And that's just 3 minus 2 root 2. And all of this is equal to 2. So we have x squared plus 3 minus 2 root 2 x squared plus root 2 minus 1 times x squared equals 2. And we can use this to find the value of x squared, and subsequently we can find a squared, which is what the problem asks for. So let's factor out an x squared. We have x squared times 1 plus 3 minus 2 root 2 plus root 2 minus 1 is equal to 2. And now the 1's cancel out, and we're left with x squared times 3 minus root 2 equals 2. So x squared is just 2 over 3 minus root 2. I don't want a square root in the denominator, so we can multiply both numerator and denominator by 3 plus root 2. And this is equal to 6 plus 2 root 2 over 3 squared minus 2, which is 9 minus 2, or just 7. So x squared is equal to 6 plus 2 root 2 over 7. We want a squared, not x squared. So we got to multiply by root 2 minus 1 squared. We have a squared is equal to 6 plus 2 root 2. Root 2 minus 1 squared is 3 minus 2 root 2 over 7. This is the value of a squared. Now this is equal to 18, 6 times 3, minus 6 times 2 root 2, which is 12 root 2. And then plus 2 root 2 times 3 is plus 6 root 2. And minus 2 root 2 times 2 root 2 is minus 8. And all of that over 7. This is equal to 10 minus 6 root 2 over 7. And going back up to our problem, in the answer choices, we see that 10 minus 6 root 2 over 7 is equal to answer choice A. So we circle A, and we are done. Thank you for watching my YouTube video. I hope you enjoyed, and please follow my channel if you would like to see more videos.